Here's a recap of the intro quiz. I'm not going over all the answers. I'm going over the concepts. You follow what I do, you might be able to fix what you did wrong. First, you were asked to make some estimates. You had to know the length of an object in the metric system. How wide's this bottle? You'd probably use centimeters. You know, maybe about 5 or 6 centimeters would do it. How about the mass of the bottle? Well, that's going to be maybe in kilograms. It's a glass bottle, probably 100, 200 grams. 100 grams, 0.1 kilogram. Remember, we passed around the kilogram mass in class, and we said that it weighed about 2 pounds. That should help you. How about the volume of the bottle? Well, you could look it up right on the label, 250 milliliters. Don't forget, I showed you what a cubic centimeter looks like in class. There's 1 cubic centimeter right at the tip here. 1 centimeter by 1 centimeter by 1 centimeter, that's a milliliter. So if this is 10 of them, take a look at the bottle. It gives you a rough idea of the size, the volume of what we're talking about. So 1 milliliter equals 1 cubic centimeter. You should know that from chemistry. I had the clear empty container on my lab table, 10 centimeters by 10 centimeters by 10 centimeters. That's 1,000 cubic centimeters. That's 1 liter. Now you have something to compare the objects that I'm asking you to look at. You can't write 1 liter cubed. That's a liter. It's already in volume. You don't cube that. You cube the length dimension. Then we add some conversions. So you need to know some prefixes for this. Here's a simple example. How many kilograms are in 35 milligrams? Start by writing down what you know. Start using conversions. If you want to get rid of milligrams, they go on the bottom. Grams go on top. So how many milligrams are in 1 gram? 1,000 on the bottom, 1 on top. Where do the grams go? I want to get rid of them. So I put them on the bottom, kilograms on top. There's 1,000 grams in a kilogram. Now we can see that grams cancels with grams, milligrams cancels with milligrams, and I'm left with kilograms. 3.5 times 10 to the minus 5th kilograms. Let's say a hose is filling a swimming pool with water at 6 gallons per minute. How many kilograms per second is this? Write down what's given. Start converting. Minutes is on the bottom. We need seconds. I'll put minutes on top, seconds on the bottom. We talked about this in class, that 1 gallon weighs 8 pounds. You can get a conversion through this from a pint a pound the world around. 1 pint of water weighs 1 pound. And we have 2.2 pounds is what 1 kilogram weighs. Let's check the units. The pounds cancel, the gallons cancel, the minutes cancel. What are we left with? Kilograms per second. That works out to be about 0.36 kilograms per second. If you're not sure about any of the conversions, check the chapter notes. There's a nice table in there for you to use. Then we had a few trig problems. Here's a simple one. That's a right triangle. Find theta and y. If I use cosine theta equals adjacent over hypotenuse, I can now use inverse cosine and solve for theta. I get 44.4 degrees. We can use sine equals opposite over hypotenuse to get y. Do the math, you get 19.6 centimeters. I'm including the units in my answer. If you have an angle and it's in degrees, you need to write degrees. Now you could double check this. You don't need to use sine. You could have checked it with Pythagorean theorem. Then we had a problem where I expected you to use the law of sines. This is pretty simple. All we're doing is taking the side and dividing by the sine of the angle corresponding with that side, setting it equal to another side divided by the sine of the angle that corresponds to that side. We get 8.87 centimeters for B. Now, how do I get side A? I need the corresponding angle, which can be found from the fact that the triangle has 180 degrees. I can set up the same relationship here and say it's equal to side A divided by the sine of the corresponding angle. And we get 15.2 centimeters for this side. The last trig problem looks something like this, and I need you to find L. Now that's going to require a few steps. You might recall in class that we learned that that angle is the same as this angle. How do I know? Well, let's just say that was 30 degrees. If that's 30 and that's 90, this angle up here is 60. Well, that's also 90 degrees. So if that's 60, that's got to be 30. So we've got the same angle here as we do here. So if I can get that angle, I think I can get L from the 25. How do I get that angle? I can use tangent. Opposite over adjacent equals tangent theta. So if that's 33.7 degrees, that's 33.7 degrees. Well, now I have a right triangle and I know what that angle is. 25 is adjacent to the angle. So I'm going to use cosine theta equals 25 centimeters over the hypotenuse. I get 30 centimeters for L. Now that's not the exact problem that we had on the quiz. If you see how we piece things together, you might be able to figure out what you did wrong on yours. And then we had a little statistical analysis. The scenario is that we had two factories producing objects. Factory A had that mass for each object that was sampled. Factory B, we pulled out these masses from a sample. We needed to get the mean and the mean deviation. That means we have to add up all the measurements and divide by 4. That's how many we have. And we get 17.75 grams. Doing the same in this column, I get 18.5 grams. So this points to the middle of the data. That's the average for this column, that's the average for that column. But it doesn't tell me what the variability is. That's what this measurement does. We're supposed to take the mean and then subtract each one of these data points, add up the difference, absolute value, and then divide by n. It gives us the average of these deviations. I get 1.25 grams. I apply the same formula over here to this column, and I get 0.3 grams for the mean deviation. Now let's say the theoretical value for each one of these objects should have been 18 grams by design. The question now is, which one of these factories is producing a more accurate product? Which one is producing more consistent results? Meaning, which one is more precise? Our mean here is 17.75, which is pretty close to 18 grams. That one's 18.5 grams. That's further away from the theoretical value than this one. This factory is more accurate. It's closer to the target. This one's more precise. The data is closer together. So you should be able to learn from this, fix your mistakes, talk to your friends, figure out what's going wrong,